Hi everyone, I'm Charlie, and this is the ring shear tester, more commonly referred to as the Schulze shear cell. We use this to study the flow properties of powders, such as bulk density, wall friction, and the flow function coefficient. Let's have a look and see how it works. First of all, we have the powder sample vessel. We simply combine this with the metal mesh shown here, and it's ready for sample preparation. Next, we take our sample, in this case it's unwashed glass beads, and fill the sample vessel. Hopefully you'll be a bit more careful with your sample than I was with mine. Once the vessel has been filled, we then level off the top and weigh the sample. Meanwhile, on the computer, we want to set up the connection and switch on the device. This will take around 20 seconds for everything to initialize. Once the connection between computer and device is complete, we can begin to choose our shear settings. So we can now describe our sample, and we choose unwashed glass beads, as that's what we're using, and then we select the order, which is 1. Now we need to input the normal loads. So first we choose our pre-shear normal load of 7,000 pascals, and then we want a nice linear difference between each of our values, so we have a difference of 1500 pascal between each of the normal loads. Then we just need to add each value to the test run and put them in order. We then simply need to input the mass of the sample, which includes both the vessel and powder weight. We're then able to start the test. Once we confirm that our vessel is in agreement with the console for the various windows that pop up, we can continue with our experimental setup. We need to first place the vessel into position, and when you do this you'll be able to feel the 3 pins on the stage lock into place with the base of the vessel. We then want to very gently place the guiding bar on top of the shear cell vessel, ensuring that the side of the bar with 2 grooves on its end is facing towards us. Next, we take the loading rod, as shown on screen, and simply lift the top part of the device and lock the rod into position with the shear cell beneath it. We then take the connecting rod and slide it through the ring and latch it onto the nearest groove found on the guiding bar. Finally, we just need to connect the 2 tie rods onto either side of the shear cell and pop them into place in the grooves on the guiding bar. And now we're free to begin the test. We can then sit back and relax whilst the shear cell does its thing and applies the normal loads that we requested. During the test, the powder is sheared until it begins to flow. Once the test has been completed, we're rewarded with the exciting task of performing some data analysis. We just need to import our data, which will be listed as whatever we saved it as. We then display the yield loci, which greets us with the Mohr circle. The Mohr circle is very helpful in calculating stresses in many planes, as it reduces them to their horizontal and vertical components. We can see that the software has determined our bulk density, sigma-1 value, and flow function coefficient, amongst other properties. I'm sure you're all aware of what density is, but you might be less familiar with the others. Sigma 1, 2, and 3 are the principal stresses in their respective dimensions. The flow function coefficient is the ratio of consolidation pressure to cohesive strength and is used to give a rough guide to the flowability of powders, where anything less than 2 is very cohesive, between 2 and 4 is slightly less cohesive than this, between 4 and 10 is easy flowing, and anything greater than 10 is free flowing. This means that our powder sample of glass beads is extremely free flowing. Thank you for listening. I hope you enjoyed the video and learned something new.